Welcome everyone to the Ionic and Capacitor workshop. I'll be your instructor, Mike Hartington. If you have any questions about the workshop, feel free to reach out on Twitter. My handle is mhartington. So for the uninitiated, what is Ionic? Ionic is a collection of UI components and tools to help you build mobile apps, progressive web apps, all with web technology. We give you components like buttons, tabs, and navigation components, as well as animations and gestures, so that way you can focus on building your app instead of focusing on how to build these components and common interactions that you see in modern apps. When you go to load up your app on an iOS or Android device, we make sure that these components feel right at home by mimicking the native design languages of each platform. This means an iOS app should look and feel like an iOS app, and an Android app should follow Material Design. But when it comes down to making your app feel unique and following your own company's branding guidelines, we make sure that you can customize it so that way your app feels right for your platform and for your own brand. These components range from the smallest possible icon and toggle to complex components that are built up of many smaller components composed together. The gestures and animations are all built in from Ionic, but can be customized to fit your own needs and even be customized to fit accessibility options like prefers reduced motion on your devices. And in addition to all of that, there are also a collection of CSS utilities that allow you to scaffold out your app using just CSS classes without you having to write the CSS for them yourself. So for a quick example, here we have a card component built up of a few different subcomponents that are all part of the card family. We have the outer ion card, which gives us the drop shadow, the rounded corners, the general shape and sizing of our card. But then we have an ion card content, which gives us this inset area where our content and our text can be safely padded from the outer bounds of the component. The card subtitle and card title are also their own components and allow the typography and styles to feel natural to that card and to that platform. If we were to look at how this behaves on Android, the subtle changes can automatically be noticed between the drop shadow being less prominent in the Material Design version, the overall typography being a little bit smaller, and the type itself being of a different font. All of this is provided out of the box, and the HTML that you end up writing stays the same. It just adapts to the platform that you are deploying to. Now, Ionic allows you to use whatever framework you're comfortable with or no framework at all. It's framework agnostic, but adapts to the frameworks by authoring a set of wrapper components that target the native framework and their native component API. This means when you're working in a React or Vue project and you need to import the components into your app, it behaves like any other UI library for those frameworks. When it comes time to integrate with the router, Ionic provides its own router outlet component that automatically integrates with the built-in router APIs and provides the animations and gestures for creating a more app-like routing experience. Before we dive into that, what is Angular? Angular is a modern web developer's platform for building amazing apps using a few core concepts. First, Angular makes use of templates, components, and decorators when building out features of your app. You start off with a component decorator, which provides the HTML, styles, and tag name for your component, and then a class that provides the functionality for your component. To build your entire app and all your components, Angular provides its own CLI tooling that will compile everything down to vanilla JavaScript that can be shipped off to the browser in an optimized manner. As your app requires more features, Angular provides a set of schematics for generating components, routes, and other feature set to make sure that your codebase stays as consistent as possible, meaning that devs should be able to jump to project and feel familiar in the codebase right away. And with that, let's get started building our app by going over to our terminal and verifying that we have a few things installed. First, we'll want to verify that we have Node installed by running node-v, and then verify that we have npm installed by running npm-v. If you don't have Node or npm installed, visit the Node.js website and download a recent version of Node, preferably the LTS version. With Node and npm installed, we can first start off by installing the Ionic CLI by running npm install-g at Ionic CLI. We can verify that we have the Ionic CLI installed by running ionic-v and seeing the version number printed out. Now, if you run into an e-access error on a Mac or on a Linux machine, be sure to run this npm install command with a sudo in front of it. If you're on Windows, be sure to install any global package from an admin prompt. With the Ionic CLI installed, we can create a new app by running ionic start and then walk through the prompts that are presented to us. For this, we're going to use our command line to create our app, so we'll enter no. And then we're presented with the option of our framework of choice. In this case, we are going to select Angular, so let's hit enter. And then we're prompted to give our app a name. For this, we're just going to use the name my app. And then we are prompted to select a new template before getting started. Now, Ionic provides a collection of different templates to help you get started, everything from a tab space layout to a side menu layout to full conference kitchen sink style apps that include every single component. For our use case, we are going to select the blank app and then hit enter, and then it will create our project and download the necessary dependencies for our project to function. With our project created, we can cd into it by running cd my app. With our project created, let's open up our editor and take a look at what our CLI command has created for us. For starters, we have a Git repository, some end-to-end tests, a source directory, some config files for browser lists, editor config, ESLint, and an angular.json file, which is an Angular specific file that'll tell us how our app gets built, how we serve it, how to run tests, and so much more. The most important part here is that if we come down to this build entry in our angular.json, we have our main entry point, which is the main.ts file, which is located in source and then main.ts. Now, this is your standard Angular bootstrapping file. We can see we have our imports for whether or not to enable production mode, our platform browser for dynamic testing, our app module, some environment files, our app module, our environment variables, and then this platform browser dynamic.bootstrap module, passing in the app module that we want to bootstrap, and then catching any errors that could happen. Since we're bootstrapping the app module, let's take a look at what that is. This is located in our app folder inside of the app.module file. And here we can see our standard Angular ng. And here we can see our standard Angular ng module but you'll notice a few different imports, specifically from the Ionic Angular package. Specifically, we have this Ionic module and this Ionic Route Strategy class. The Ionic module is responsible for declaring and providing all of the necessary components and services that come from the Ionic Angular package, while the Ionic Route Strategy class is used to tell Angular's router how it should handle old routes and navigating to routes with the same URL parameter. To make use of these, we add them into our import statement and say .forRoute on the Ionic module, and then tell Angular's router about the Ionic Route Strategy class by using the provide use class pattern for our providers. With all this in place, let's open up a new terminal and then start our live reload server to see what our app actually looks like. To do this, we can run the command ionic serve, which is going to run ng-run app serve under the hood. This will start up our Angular dev server and start to compile all of the Angular source code beforehand, and then open up the browser. Let's go back to our editor and then resize our window and take a look at the markup that is being used to generate our UI for our app. Our app now loads everything from this routing module, which, if we were to take a look at, provides a set of routes for our app to be able to navigate to. If we land on what is essentially the index of our app, we get redirected to home, and then home actually loads another module, which is split out to create a lazy loaded chunk. This lazy loaded chunk is this homepage module, which automatically loads this homepage component and the accompanying HTML for its template. Now, automatically, you should be able to see that we have some components in here that are non-standard HTML components. These are built up of Ionic components, as we see here in the header, as well as some more further down in this Ion content. Now, hopefully it's clear that this Ion header, toolbar, and title component are the same components that we see over here in the browser version. So this blank title over here is going to the Ion title. The overall bar component that we have here is from the Ion toolbar. And then wrapping all of this, giving it some intrinsic sizing so that way it is laid out correctly within our whole component, is the Ion header, making sure that everything is set up for Flexbox and that it will resize automatically. For example, if we were to come down inside of our Ion header, copy this toolbar, and then paste it below it, and save our file, our header is automatically going to resize to correctly lay out that toolbar and adjust the Ion content to fill the rest of the available space. Speaking of Ion content, if we come down to the Ion content, we should see another header and then this standard div and some paragraph tags, but the second header seems a bit odd. So what's going on here? Well, the second header actually becomes pretty obvious if we were to go ahead, open up the DevTools, and then enable device emulation by clicking this little device icon up in the top corner. Now, we'll reload the page and notice that the Ion title and toolbar itself looks a little different. This can become more obvious if we were to come over to our component and just generate some random text, something like item $, times 40. And then we'll just generate 40 empty paragraph tags. We'll save. And then if we go back over to the browser and we start to scroll, the header actually starts to disappear. And then we see another header appear on top of that. So what's going on here is that this second header inside the Ion content is being shown when the scroll position for the Ion content is basically 0. So we have this large header indicated by the fact that our Ion title has a size property, and that property is set to large. And then the header has a collapse property, which its value is set to condense. So that way, as users start to scroll in their app, the header starts to disappear. The main header that we see at the top of our app actually starts to show up. And then we have this very nice experience that feels close at home to what an iOS app would do out of the box. Now, you might be asking, why is this app so dark? Why does it look like it's just set to a black background? Well, that's because we're making use of some CSS properties and CSS media queries to be able to adapt to a user's preferred color scheme. So here in source theme variables.scss, we have these custom CSS properties which are used to theme an entire app. If for some reason you want to change the primary color of your app, all you needed to do would be to change a few of these properties, and then your app would look completely different. For our use case here with the dark background, if we were to scroll all the way down, we have this app media prefers color scheme. So this basically says, hey, if the user has dark mode enabled on their device or their browser, let's go ahead and use these colors instead. If we didn't want to use this dark mode, we could just select it, delete it, save our file, and we'd go back to the standard bright background and dark text for the foreground colors. But keeping the media query in there allows the app to feel more at home to these native platforms, which automatically get a dark mode built in by the native tooling. So by just having a simple little CSS media query, users could toggle their light and dark mode and have the apps automatically adjust based on their preferences. Going back to our homepage component, let's start to modify this and incorporate a few more Ionic components. One of the first components that makes sense to go over is probably the most basic. So we'll come down to our Ion content and delete everything that we have inside of there. Save. And we'll add an Ion list and start to add our Ion item, the first component we'll look at. For instance, if we go inside of this component and we render our first little bit of HTML, which will just say item, we'll save. If we were to go to the Dev Tools, go to our Elements tab, select the item, we have first off a shadow root and then a few slot positions where we could start to render some elements inside of our Ion item. Now, the shadow root and slot elements are all part of a web component standard, part of the core component features that Ionic ships with, but we can make use of these inside of Angular the same way we could make use of these in any framework. So for instance, if we come back to our editor, we could create another element and say slot item. And if we save this, well, it's just going to render next to our main item. If we set the slot property on the element and set its value to be start, when we save, it's going to render to the side of the ion item. And if we change this to be end, it's going to render after the ion item, giving us this nice way of controlling where elements get rendered that isn't dependent on the markup being used here. So this paragraph tag could come after or before the element. It doesn't really matter. This slot property is controlling where this component gets rendered. Now, before we move forward, let's do some housekeeping around this item. So that way we have more than just a single item inside of our component. So in our homepage.ts file, let's create a property on this class called items. And then this items property is going to equal an array. And inside of this array, we're going to create an object where the key is name and the value is note, where we will use template strings to generate a new unique identifier where we'll just say date.now, and then we'll push an ID of just 1. With this in place, when we go back to our home page, we can now start to use our items array as our iterator for an ng4. So we'll say star ng4, and then we'll say let item of items, and then we'll replace the item text inside of this little paragraph tag with an double curly braces and say item.name, and then inside of the paragraph with the slot end, we'll change that to be double curlies item.id, and let's change the position of this item.id to be at the start instead. We'll save, and then our template will update to reflect that. Now, our single item is a little bit boring, so how could we go about adding some new items to this list by following the same pattern of having an item with a unique identifier and an ID? Well, we can start to make use of a few other components that come from Ionic, most notably the Ion buttons and Ion button component. So to get started, we will add an Ion buttons component, and then we're going to actually set its slot property to equal n, meaning that we want this collection of buttons to render on the right side of the Ion toolbar. Inside of this Ion buttons component, we'll render an Ion button, and then we'll just add its text to be add. When we save, we'll automatically get a little button at the top that says add, and everything should be looking pretty okay. In most cases, though, we don't necessarily want to actually use text. An icon can represent the same kind of information in a smaller payload and not require users to have a translation for localization. So let's get rid of the text, and we'll add another Ionic component, this one called Ion icon. And to get the correct kind of icon, we'll set its name property, and we'll give it the name of an icon we'd like to use. In this case, we're going to use the add icon. And when we save, we'll notice we just get an icon that has a plus sign. But to make sure that we have this positioned exactly where we want it, we will add another slot property here. This time we're going to set the value of this to be icon only. And this is going to tell the icon to render in the slot called icon only. So that way we're going to take up the appropriate size and spacing for this Ion button. When we hit save, our button is a little bit bigger, it's sized correctly, and everything looks good. To add the functionality to add a new item, let's attach a click handler here, and we're going to call a new method that we haven't created yet, calling it add item, and then we'll save and go back to our homepage.ts file and create the new method called add item. And then inside of this add item method, we're going to create a new item variable. And then we're just going to set its value to be our existing item object. So this will generate a new date. But instead of using an ID of 1, we're just going to say this.items.length plus 1. So that way we can make sure that we have the correct index for this. And then what we'll do afterwards is say this.items equals a new array. And then we'll use the spread operator to iterate over the existing items and then add it off with a new item entry that we just created. When we save, we should be able to go over, click the button, and then add a new note, automatically iterating over not only the ID, but a new unique identifier based on date.now. So if we wait a little bit and then click the button again, the unique identifier is going to increment every single time we click the button. So our app is looking pretty good. With this in place, we can start to think about how we can remove items based on their status if we were to build this out to be something a little bit more complex like a to-do app or a task tracker app. To do this, we can start to make use of some more advanced list items based around a component called Ion Item Sliding. To make use of this, let's go ahead and create our Ion Item Sliding. And then let's move the Ion item from before inside of it. And then we're going to remove our NG4 and then place it on the Ion Item Sliding component. So now our Ion item is being wrapped by this Ion Item Sliding. We can save, and our app should generally look the same. From here, we can start to use two other components to add some sliding item options to our component. So inside of our Ion Item Sliding, and as a sibling to the Ion item, we're going to create an Ion Item Options component, and we're going to set the side for this to equal end. Inside of this Ion Item Options, we have the component Ion Item Option, which is a singular option that we could click, and we're going to add the text, remove. When we go ahead and save our file, back in the browser, we should be able to swipe to reveal this remove button and then be able to interact with it to target our component however we see fit. Now let's add a click handler here to our remove button, and we'll give it a new method called remove item. And then we're going to pass in the item that's used from this ng4, so that way we can remove only the specific item that we want. So we'll save here, go back to our homepage component class, and then we'll create our new method called remove item, and then give it the item that we are going to remove. Now, to remove the item, we're going to come up to our method and we'll say this dot items is going to equal this dot items dot filter, and then we're going to take each entry from here, and then we're going to iterate over each entry in our original array and return the entry if its ID does not match the item we pass into our method. So we'll say if entry.id does not equal item.id, we'll then return entry. And then let's just go ahead and slap on the types for this. So we'll say that the type for our item is an object with a name that has a type of string, and that it has an ID, which is a type of number. So when we save here, we can go back over to our app, add a few new items, and then let's remove item 2 here. We'll swipe to reveal the item options, and then we'll click remove, and then our item has been removed. So this is a really nice pattern for having some options and having some interactive items that our users can use. Now, while our app works pretty well, the way in which we add items to the list is a little bit off, as we should be able to add a custom name to the note or add some more comments to the note itself, since it is just an in-memory object. So to customize how this note creation or item creation process is being done, we're going to introduce some Ionic overlays to our app. To start working with our overlay, let's go to the top of our file and we're going to add a new import statement. And we're going to import this from Ionic Angular. And the class that we're going to import is the Alert Controller class. From here, we're going to go down to our constructor and we're going to inject the alert controller into our component. So we'll create private alert CTRL, so alert controller for short, and it's going to be a type of alert controller. Now, with that in place, we can come to our add item method, and we're going to start to modify how this works. So the first thing that we need to do is add the async keyword to our method, since all alert controller methods and all overlays from Ionic are promise-based. So we can use async await here to create a kind of synchronous style of programming instead of having to deal with promises and .then. With our method being async, what we can do now is create a new alert instance, and then we're going to say that this alert variable is going to equal await this dot alert controller dot create. Now, our dot create is going to return an instance of a alert component, and the create method is going to be how we customize what text actually gets shown in the alert. So for our alert, let's go ahead and add a new entry here into our options saying message, and that this message is going to be a string where the string will just say create a new item. And then below this, we're going to say await alert dot present. And for now, we're just going to comment out these other two lines. We'll save. And when we go to click on our alert, we'll get an alert that shows our message, create a new item. Now, to be able to enter text into this alert, let's go back up to it, and we're going to add a new property inside of our create method called inputs. And the inputs are going to be an array of different inputs. So for these inputs, we can start off with an object, and we'll say, what is the type? Either a checkbox, radio, text area, or just text. So we'll say that this is going to be a text input. Its name is going to be new item name, and then its value is going to be null for now. Now, we could add more fields here. So let's add another one, and this is going to be content, and value is still going to be null. So basically, we'll create a new input for the new item name, and then another input for the new item content. Let's go ahead and save this and test it out by clicking our add button. And now we have the input name and then the input for the new item content. From here, we can add a new entry, and this is going to be for a collection of buttons, which can either be an object or a string, but are an array of buttons that we want to present below our inputs. For example, we could have a button where there is some text that says save. There is a role which can be used for custom styling, and we can say save, and then we could attach a custom handler to perform any kind of validation on this button, whether or not we should be running a function or we should check to see if an input's value is actually set. We could do a lot of things here. If you don't need that complex of a button, a simple string will do the same exact thing, just removing the need to create your own handler. Let's save this file, and then we'll open up the alert. And we can see we have an input for the name, an input for the content, and then our new save button, which will push the name and content onto our items array. So with the alert the way it is right now, when we click save, nothing actually happens because we have no handlers for when the alert has been dismissed. So let's go ahead and add that to our alert. So what we can do here is say alert.onDidDismiss, and then we will start to chain the promise here. And we're going to assume that there is going to be a result coming from this onDidDismiss, which will contain the value of our inputs. So we'll get that result, and then we'll create a new function in here. And for now, let's just console.log the result. We'll save. And then go to the browser, and then we'll open up our console tab. And then if we were to open our alert, we'll enter a title. We'll say a new item. We'll have some content in here, some content, and then we'll click save. We now have the data coming out of that alert. If we expand it, we can see we had the data, which contains an entry for values, which then contains 2 keys for new item content and then new item name, the same values that we have here in our inputs. So whatever we name these inputs in the alert controller.create call is what they will be named when we try to access the results in onDidDismiss. So with this in place, we can now start to add back our new item and use the results to populate the name and then the ID. So first, we'll want to get the new item name and new item content by destructuring result. So we'll say const new item name and new item content are going to equal result dot data dot values. Then down in our new item, we'll replace the hard-coded name of note with the new item name. And then we can get rid of the ID since it's not really used anymore. And then we will use a new entry called content, where the content is going to be the new item content. From here, we can just take the line of this.items and then add that back to our mix. We do have an error, and that is the signature has changed. So we need to go back and redefine what our items should look like. So to fix this, we'll go further up our file. We'll get rid of this ID, replace it with a content, and then just set the value to be an empty string. And then we also need to fix our item down here where instead of an ID, we just say content string, and then we'll compare the item name and then the entry name instead. So now we've basically fixed all of our typing issues and we can save. So if we come over to our app and we click the add button, we can give it a name like new item and then some content like this is my content. Then when we click save, we should get a new item plus a random generated date, and everything should just work. The only thing that we have to fix is the old item ID not displaying. And to do that, we're just going to use the index in our ng4. So back in our homepage template, we'll just say let I equal index in our ng4, and then this item ID entry over here, we can just replace that with I. When we save, the index will be shown right next to the item. Now our app is working fine. We could add a new item here, say new item, some random content, and we could save, and that's working great. But if we reload the page, we essentially lose all of that data. We have no way of persisting them to the browser. Everything's just done in memory. So to fix this, we're going to make use of Capacitor and its API for accessing the file system. But before we dive into that, let's take a look at what Capacitor actually is. So, Capacitor is a companion project to Ionic that allows you to take your web app and then build and deploy it for iOS, Android, as well as the PWA, but still have access to features like geolocation, camera, file system, and local notifications. So, with Capacitor, you simply have to install the Capacitor CLI in the core library, and then you can start to add and target the platforms that you might want. When you want to access the features that comes with Capacitor, you install the plugin and then you start to call the plugin APIs directly. For example, if we want to incorporate local notifications into our app, we'd simply install the Capacitor local notifications package, import it into our app, and then start calling the methods on the plugin itself. So here we're just calling schedule and then passing in an array of notifications that we would want to display to our users. Same thing can be done for in geolocation, camera, and then any custom plugins that we could want to create as well. Now, there's quite a few features that we have here, not just camera, geolocation, and local notifications, but we also have file system, accelerometer, network, haptics. Basically, any API that is available on a native platform is also available through Capacitor. And the best part, I think, is that Capacitor is not tied to any specific framework. So you could use it with React, Angular, Svelte, Vue, or no framework at all. Now, while the point of Capacitor is to target native, I'm not going to spend too much time explaining how to set up your native development environment. Instead, we have a full dedicated guide here in the docs. And under getting started, we have environment setup, which shows you how to set up your environment for iOS development as well as Android development. If you want to start working with the native platforms like Android, this guide will help you get up and running and make sure that you have the necessary software installed. For our needs, we're going to look at the plugins, go to the official plugins, and then we'll scroll down and choose the file system to see how to install the file systems plugin and how to add it to your app. The file system API from Capacitor gives you a node-like API for working with files on a device and in the browser. And if we scroll through some of the method names, we have things like write file, read file, directory operations like makedir and rmdir, which should feel very familiar to anyone who's worked with Node's file system API or your standard Unix file system API. So to start using the file system API in our app, let's open up a new terminal and let's install the Capacitor file system plugin. We'll run npm install at Capacitor and then file system. Now back in our editor, let's go back to the home page. And now we can start to think about how we want to incorporate the file system features here in our app. So some obvious features that we want to have is we want to be able to make a directory. We also want to be able to make a file. We'll also want to be able to remove a file. And then the most important one, we'll want to check permissions. With these 4 methods, we should be able to handle all of our file operations for this app. So to get started, let's go to the top of our file and let's import from Capacitor file system. And we're going to import 3 symbols from this package. the file system class itself, the directory enum for picking where we want to store each file, and then an encoding enum to make sure that we are reading and writing files in the correct encoding. From here, we're also going to import the on init lifecycle hook from Angular core, and then make our component implement the on init lifecycle hook. We'll come down to our component, and right below our add item, we'll add our ng on init method and start to use this as our place for chaining some of these file system operations. So in our ng on init, we want to make sure that we have permissions. Then, if that's successful, we'll want to call this dot makedir, which is going to create our new directory for us to save files to. Then, if that's successful, we'll want to call this dot readdir to be able to read the files from that directory. So let's go about implementing this. In our check permissions method, all we're going to do is mark it as a sync and then say, await file system dot request permissions. Since all file system operations and all operations inside of Capacitor are async, we can use async await here to make our calls much more readable. From here, we'll go to our make directory call, and we're also going to mark this as a sync. And inside of this, we'll write try and then call await file system dot make dir. And then we need to pass in some options in our make directory call. Now, inside of this call, we need to pass in a specific directory where we want to start to make this new directory, and then the path or the name of the directory we're going to create. So it sounds like I'm saying directory a lot. What's the deal with that? Well, when dealing with apps, we need to be able to have a sandbox location for where we can make all of our file system operations. So to account for this, we can use the directory and then the directory enum to specify which sandbox location do we want to use. For instance, on iOS, there is a sandbox documents folder where any file system operations are performed and isolated to that one app instance, instead of having a global document store where all of the files could either clash or be accessed from different apps. This way, our file system operations stay secure and isolated to this one app instance. With that, we also need to pass in the path, and then the path is going to be the name of the directory that we're going to make. So we will call this my notes. And if this fails, for instance, if the directory already exists, we should be able to catch this. So we'll say catch, get the error. And then for now, we'll just console.log, and then we'll print out error followed by the actual error message. So that way we can have some sort of feedback when we are debugging our app. Now from here, we need to create a new method. We're going to say async readdir. And then inside of our readdir call, we'll create a new variable called notes. And this is going to equal our call from the file system where we say await file system dot reader. And again, we're going to pass in an object with some options for how we're going to read this directory. So we will give it the sandbox of directory.documents, and then the path will be my notes. From here, we can say this.items is going to equal notes.files. And now we just need to adjust again our signature to make sure that our items follow the same signature as files. So starting from the top, let's come to our items, and instead of it being an array with some predefined content, we're just going to make it an empty array and then give it a signature of string array. So that way we can say we're going to have an array and each entry in that array is going to be a string. Further on down, we have our results, which we'll get to this for now. So let's just comment this out for now. And then further on down, when we try to remove an item, let's just comment this out for now. Save this file. And then go back to our homepage.html to adjust for some of the changes here as well. So we'll get rid of the item.name and we'll keep this the way it is for now. So back into our homepage class, we are now making our notes directory and attempting to read the file system. Since we don't actually have any notes in our file system at the moment, we need to adjust our add item method to write to the file system. So back up in our alert on dismiss handler, we have our results, and then we have the new item name and then the new item content. So let's go ahead and create a new call here where we'll just say this.makeFile, passing in the new item name, as well as the new item content. We'll be sure to make sure to return this call, and then we can go down to our make file, and then we're going to get the new name as a string and new content also as a string. And we're going to make this make file call async because, again, we're working with the file system, so all file system operations are asynchronous. From here, we'll call await file system dot write file. We'll pass in our object again for directory, which is going to be our directory enum dot documents. The path is going to be a string where we'll say my notes, and then we'll use a expression here since we're in a template string where the first part will be new name, and then we'll add a dash and then another expression where we'll just say date.now to give it some sort of unique identifier, followed by a extension. Next, we'll want to make sure we encode it correctly. So we'll use encoding and then make sure that we are using UTF-8. And then any potential data that we want to pass along with this. And to make sure that we are doing this safely, we'll either say new content and then use nullish coalescing to say if that value is null, then just use an empty string. Once we're done with this, we're also going to want to update our items again. So to do this, we can just call await this dot readdir. We can save our file, go over to our browser, and if we click the add button, we'll set a name to be new item, some content in the content field. And when we click save, we'll have a new item in here, and then we can create another item. And when we reload, both of those items are now safely stored in the file system. So what's happening behind the scenes here? If we were to open up our DevTools again, and then look at the Applications tab, we should see that we have a collection of entries in IndexedDB. Since there's no stable file system API on the browser right now, Capacitor's file system API will mock the file system of a native device by using IndexedDB to actually store not only the content, but all the files in a organized manner. Since IndexedDB is scoped to a single domain, we now have a built-in way to scope a bunch of different files and directories all to one place without having to worry about site A and site B having the same file names and directory names. So back inside of our app, let's go ahead and re-implement all the existing logic that we had before when we were storing everything in memory. So we'll go and remove this method that we're not using, and we're going to re-implement this remove item method. We can change the type here to be just a string since we are only passing in the file name now, and we don't need this filter method to be able to remove an item from our file system. We can do this all with the file system plugin. So like before, we're going to go ahead and mark this as async since all file system operations are asynchronous. Then inside of our method, we'll say await file system dot delete file. And then we'll start to set up the options that we're going to pass into this. The first entry being the directory. So this should feel very familiar. We'll say directory dot documents. And then for the path, we'll give it the string of my notes slash, and then our expression for item. Since we're only getting the actual file name and not anything more, we just need to pass this. With this operation done, we do need to call readdir again, which will read our file directory now without the removed file, and re-establish our bindings on the class properties. So we'll say await this dot read dir. When we save, we'll go over to our browser. We'll select this first item over here. We'll swipe. We'll delete it from our app. Our storage will say data may be stale. So let's refresh it in the DevTools. And you can see we have one less note or one less item saved to the My Notes folder. So right now, the way our app is working, it's handling all these file operations. It's behaving pretty well. We got a lot of functionality without actually having to write too much code in here. But we're still in a web app world. What about native? Well, let's go back to our dev server and we're going to stop the dev server and we're going to run an actual build of our app. So all we're going to do is just use the npm run build, which is going to call ng build. And with all of our assets built out for us, let's start to add these native platforms that we might want to target. So for my setup, I'm going to install the iOS platform. So I'll run npm install and then pass in the @capacitor/iOS package name. With this installed, we can now start to call the Capacitor CLI directly and create our new iOS project. So we'll call npx cap, which is the capacitor name, just shortened down, and we'll say add iOS. Now, not only will this go and create our native project, we'll also go ahead, copy the web app portion to the actual project, and then install some native dependencies as well. As you can see, we have a native dependency for status bar, keyboard, haptics, the file system, which we've been using, and then this app API, which allows us to interact with certain features of our app in general. All of these get installed using CocoaPods, which is the native package manager for iOS projects. With the project created, let's go ahead and run npx cap open iOS, which is going to open up our project for us. Now, if you've never used Xcode before, don't worry. It should feel pretty familiar to other IDEs that you have used in the past. Over here, we have this little sidebar where we have our projects that Xcode could build for us. We have this pods project, which is going to hold all of our dependencies and give us a way to manage those dependencies in this pod file. And then inside of the app, we have the code for our actual project. So we have this app project. Inside of that, there's this app directory. And then inside of that, we have all of our app's necessary project files. Specifically, we have this app delegate file, which is where we can start to override the default behavior of our native app. So if for some reason we wanted to come in here and start to write our own custom native code, we could start to do that inside the app delegate and know that it will be available throughout our entire app. If we come back over to our app project, we can get a general overview of our project, the different build targets, and we can see a whole bunch of information on the app's display name, the bundle identifier, the various different platforms we would like to support, as well as the links to our app icon, our launch screen, and a few other details about our project. The most useful is probably going to be in this signing and capabilities tab up at the top, where we can start to select our signing profiles for building and deploying to a real device. For this one, we're just going to select a default profile and then let Xcode manage creating and updating profiles, certificates, what have you. Now, to start building our project for a simulator, let's come up to this little display bar at the top and we'll see we have app and we can see that it's trying to build for an iPod Touch. Let's just select that and we're going to select, we'll go with an iPhone 12 Pro Max. And then to start building, we can just hit this little play button up at the top. This will go ahead and start to build our project, which we can see a little progress indicator over here. With the app up and running, we can click the plus button. We can enter in our new name, new note, and then the content for this will just be some random content. We can click save, and then the new note should be appearing in the app itself. Now, what's great about this is that if we come down to our logs over here towards the bottom, we can see that we have 2 native calls and then some logs being printed out from the file system operations. So we can see a 2 native file system write file. And then to JS, we can see the return value of where that file is getting written to. And we can see we have our container, the app, the random ID that the app has been generated with, and then this documents folder going back to our directory.documents enum, storing it in my notes with the file name, and then the reader results being printed just below that as we reestablish our bindings. So as we start to call these file system APIs on the browser, we'll use a IndexedDB mock file storage system. But as we start to deploy to these native platforms, we're going to swap out the implementation and use the actual native storage systems. So the APIs that we use and that we call stay the same. The only thing that changes is the underlying implementation. So we have our app being built and being deployed to a simulator, but what we've noticed is that we've made a quick little mistake. We forgot to update the name or title being used in our Ion title. So probably a standard way of doing this would be to go to our app, go back to our editor, make the change in here, then rebuild and then redeploy. What's a better way to handle this? Well, since we are dealing with a web app that has a live reload server, why don't we take advantage of that and start up our live reload server, but also deploy to the native device? So to do this, we're going to start off by calling our Ionic Cli, and we're going to pass in the prefix of cap to say that we want to perform a capacitor operation, and we're going to run iOS, and then we're going to pass the flag live reload, and then -- external. In case we were making any API requests, we want to make sure that we can actually reach out to the greater internet instead of just being tied down to the local network. With that, we can hit enter, and then we're prompted to pick a target or a simulator. So since we already have an iPhone Pro running, let's go ahead and pick that from our list. And then it's going to go ahead and perform a sync, basically copying over our assets that are already there. Ask us to pick which network and IP we want to use for the external facing network systems. And then it's going to run our app serve task from the angular.json. From here, it's going to run capacitor run iOS, no sync, and then give it the target of the simulator we chose earlier on in this process. So our simulator has been started. We can go back over to our app, and we have the first title that we're going to change. I'll just say my notes. It'll automatically get updated, and then we're going to also be sure to update it over here. And we'll just add a note to make sure that we have the title updated properly. My notes, some content. We'll click save. We can start to scroll and see that the titles are updated. But now we also want to be able to change where this index is getting placed. So let's come back to our editor, and instead of having this render at the start position, let's go ahead and put this at the end. And we can still have our app update. So not only will this handle HTML and style changes, we could completely recompile our app and basically change everything going on in the TypeScript, and our app will automatically just reload as we make those changes. So this can be a really great process for having a fast feedback cycle as you're developing your app. From here, we can start to build out the rest of our app or start to add more native features. Or we could just go ahead and compile this app and then ship it off to the App Store. So wrapping up, we took a quick look at Ionic Framework, its components, and how to structure a new app, as well as Capacitor and how to start to work with some of the native APIs that it provides. But there's so much more to each of these platforms, and I highly encourage you to check out ionicframework.com/docs to learn more about Ionic Framework itself, and then capacitorjs.com/docs to learn more about Capacitor and its various APIs that it has available. So just to recap on what we've learned, we have Ionic for providing this cross-platform UI layer for not only web, but also for mobile, and then Capacitor, which provides a JS and native layer of tooling for targeting web apps as well as native mobile apps. So altogether, these two tools allow you to not only build apps for these different platforms, but reuse your existing skills to move faster and ship things sooner. Thank you so much for joining. If you have any questions afterwards, feel free to reach out.